Hello, welcome to my channel. The last episode under the proof of the laws of logarithm. We are taking the fourth one, the fourth law, which is what we call the change of base. So in this case, number 4 is saying that if I have the logarithm of b base a is the same as 1 over the log of what? A base b, or we can say the log of b to the base c divided by the log of a base what? C. Let's see what we are doing. It's a change of base. We are changing the base. The base in the original state was base a. The argument was b. And this can be replaced by 1 over log a base b. You can hear now they say base b. It is no more base a. We only swap the position of what? A and b. That's the change of base. Good. Or we want to introduce a different base altogether. So they are saying it will be log b, the argument. The base divided by the log of what? A base what? C. Let's see how we can prove this one also. So we are going to begin with this side. So let's say we let our log of b base a equals to p, any variable at all. If that is the case, we can convert from here into what? Indices. Meaning a exponent p equals to what? B. Now let's go back into logarithm with a different base. Say base c. So this is going to be the log of a exponent p base c equals to the log of b exponent what? C. So now we have a different base. We can remember under the third law that this becomes a power, meaning it will multiply. Meaning I'll be having p multiplying the log of a base c equals to log b base c. But p is a foreign material we introduced. So let's keep the p and divide through by what? Log a base c. Meaning p will now be equals to the log of b base c over the log of what? A base c. You can see that we prove it. Don't forget, p is what we are letting to be this. So your p is now log b base a from here, which is equals to the log b base c over the log a base c. So we have proved it. But you'll be asking, why are we not proving the middle one? Now, we can prove the middle one if we let c equals to b. So let's say let c equals to b. If c is equals to b, then we can say that our left hand side, the log b base a equals to log b base b over log a base b. And you can agree that log b base b is just what? 1. So 1 over the log a base what? B. So what happened is that if in a case you don't want to introduce a different base, you want to maintain the two bases you have by only swapping them, you have to have what? 1 over the change of the base. Meaning the base is not the argument is not the base from here. Argument is b, the base is a. The argument is now a, the base is b. That is if you don't want to introduce a different base, a different number. But if you want to introduce a different number or different base, then it means that the argument is going to be the first argument of the numerator. Then the base become the argument of the second denominator, still with your new base you are introducing. So imagine we want to simplify this. Log 5 base 25. We want to simplify this using base 10 as the log. So we are going to say that this is going to be giving us log 5 base 10 over log 25 base 10. Change of base from the log. So now, it will be easier to solve in what? A common base, which is base 10. So now we can break this into indices, meaning the log of 5 base 10 over the log of what? 5 exponent 2 base 10. You remember the third log, which is the power rule. The power comes to multiply. So I now have log 5 base 25 being the same as what? The log of 5 base 10 over 2 log of 5 base 10. And you can see clearly this is a division of log 5 base 10 over log 5 base 10, which will cancel. So this will cancel this. You'll be left with only what? 1 on top and 2. So this simply means that we have what? Half as the answer for logarithm of 5 base 25. Good. There is another trick in it when the base is a power. Let's prove that as 1. So we have the log of 5 base 25 will now be 5 exponent what? 2. So in this case, it is a base that is raising the power, not the argument. When the argument raises the power, it comes to multiply. Right? It's just coming to multiply. But here, it is coming to divide. 1 is already there. Here, it's coming to multiply 1 to give you the answer. There is 1 here, so the base comes to divide. Meaning, I'll have 1 out of these 2. The logarithm of 5 base 5. And you know logarithm of 5 base 5 simply means it will cancel to give us just what? 1 out of 2. So if you don't want to go into the change of base, you can go into what? The use of a power of a base. Thank you for watching. Like, share, and comment. Subscribe to the channel. Follow me on Facebook, Tazonomi Online Mathematics. Subscribe on YouTube, Tazonomi Online Mathematics. TikTok, Setazo. Instagram, Gapo, Fred. Yeah. Bye-bye.